Want to create your very first iOS app, but not sure where to start? Well, you're in the right place. Let's get started. Want to create your very first iOS app, but not sure where to start? Well, you're in the right place. Let's get started. Hello everyone. Before we get started, I've set up a Patreon to help upgrade my equipment. I'm aiming for a new MacBook Pro, which costs £4,000, to improve video editing and audio quality for better tutorials. If you'd like to support, the link is in the description. Thank you so much for your support. Let's jump in to today's tutorial. The app we are creating is called Breakout, also known as Wall Smashing Game. The purpose of the game is to destroy the wall by using the paddle and the ball. So the first thing we need to do is to create a new struct within your SwiftUI project. Select new file, select Swift file, click on next, name the file brick, click on create, import SwiftUI, type the following struct, brick, identifiable, let id equals to UID, var is hit, bool, var type, brick type, var durability is int, position cg rep, velocity CG size equals 0. From lines 18, we create a unique identifier for each brick, since we need to loop through each of the bricks. And then we create another variable that's called isHit, which tracks whether the brick is hit. And the brick type will include types such as normal, multi-hit. Durability is the number of hits needed to destroy the brick, as in the brick wall. Position is the position and size of the brick, and velocity is the speed and the direction for the moving brick or bricks. So we need to create another, not struct, but we have to create an enum, which is called brick type. So I just create a new file, Swift file, name it brick type, import SwiftUI, enum, brick type, case normal, case multi-hit, case power up, case explosive, case moving. So our enum for the brick type includes 5 cases: standard brick that breaks with 1 hit, multi-hit that requires more than 1 hit, and then we also have a power-up that releases a power-up when broken, explosive that explodes and affects nearby bricks, and also move around the screen. We need to create another struct, and this will be for the ball, as you saw earlier in the demo. So we call this Swift file, let's call it ball. Import SwiftUI, struct ball, var position, CG point, var velocity, CG size, trail, CG point, which is an array of points. So from lines 12, what we're doing is we set the current position of the ball and the speed and the direction of the ball and the trail effect behind the ball, as seen earlier in the demo. The next file we need to create is paddle, which is another Swift file. It's another struct, paddle, var position, CG rep, so the purpose of lines 11 is to set the position and size of the paddle. The paddle is that that little long thing that we move across the screen to reflect the bricks. We need another file, which is another struct that's called power up. Struct power up, identifiable, let ID equals UUID, var type equals power up type. We need to create that enum afterwards. Var position, CG point, var is active, bool equals true. So from lines 13 or from lines 12 we create our standard UUID, our unique identifier for each power up. And then lines 13 includes the type of power up, such as extra life or expand paddle that we're going to create afterwards. And then the position of the paddle, or the current position of the paddle. And also whether the power up is active or not. So we use is active and set it to true. It can also be set to false when we're playing the game. So we need to create another enum. And this enum is called power up type. Enum power up type, case irritable. So the purpose of the case iterable is that we need to loop through each of the cases using a for each loop. So the first case that we'll create is called expand paddle, which increases the paddle size. Case extra life, case slow ball, which slows down the ball speed. Case extra ball, which adds an additional ball to the game. So there could be two balls whilst playing the game. Case shrink paddle, which decreases the paddle size. Case magnet paddle, which makes the paddle attract the ball. Case reverse controls, which reverse the controls for the player. I'll just save it. In next week's tutorial, we'll start to implement the actual UI for the game, which is the content view. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Want to create your very first iOS app, but not sure where to start? Well, you're in the right place. Let's get started. In this tutorial, we will start to create the bricks and the paddle. So the first thing we need to do is to create a new SwiftUI file. Hold down the control key, left click on the mouse, and then select new file. Select SwiftUI view, click on next, and call the file breakout game view. Within the new created view, we will add some at-state variables. So after lines 10, enter the following: at-state, private var, balls, ball, position, CG point, X 200, Y 400, velocity is G, the CG size, width and height. So the width is 4 and the height is -4. So the purpose of the at-state variable on line 11 is to set the position of the ball and the speed of the ball using the velocity that we'll implement later on. At-state, private var, paddle equals paddle, position CG rec X 150, Y 500, width 100, and height 100. No, height is 20 pixels. So the purpose of lines 12 is to create the paddle with a width of 100 pixels and a height of 20 pixels. Next thing we need to do is to create an array of brick objects and also create an array of power-ups objects in line 13 we need to include the word var or the keyword var to declare the variable var. We also need to create an array of particles to have a particle effect. The particle objects or the class, it doesn't exist as yet. So yeah, we can just create it now. So let's create another file, which is a Swift file. Name the file particle. Struct particle. Identifiable. So particle has an ID, a unique ID, has a position, CG point, which is the current position of the particle on the screen. It also has a velocity that includes the direction and the movement and speed of the particle, which will be CG size, var size, which is the size of the particle, in radius, which will be CG float, var color, which is the color of the particle, and then var opacity, which is double. And this is the opacity of the particle as in transparency level. So we need to go back to the breakout game view. And I missed that bar again. Keep on doing that. enter the following at state private var game timer, which is optional, and that's a time loop for the game. At state private var score, which is 0. At state private var lives. The player has 3 lives to start with. At state private var game over equals false. At state private var level is 1. Each time when the game starts, it always starts from level 1. At state private var paused equals false, which will enable the user to pause the game. At state private var magnet active, which is false, and that's a magnet power up state that we'll implement later. At state private var reverse controls, which is false. And then we need a constant, which is called number of columns, which is equal to 6. We can delete line 28, we don't need it. Add our geometry reader. Within our geometry reader, we will add our V-stack, and then we color our V-stack using a black color. Whilst ignoring the safe area, and then we loop through each of the bricks using a for each. If not, brick is hit. So we create a rectangle for the brick, and then we fill the brick with color. we need to create a new function called brick color that will return the correct color for the brick. Private function brick color for brick. Brick. And then that returns a color object. Switch brick dot type. If the brick is a normal brick, then just return blue for the color. If the brick is a multi-hit brick, return orange. If the brick is a power up, then return a purple brick. If a brick is an explosive type brick, then return red. And then if the brick is just moving, then the color will be a cyan brick. Oh yeah, there's another brick I've forgotten to include, which was that's correct for the brick color function. At the moment, we don't need any more cases. So the next thing we need to do is to go back to line 36. And then we add the following: dot frame, so we set the frame for our brick. So the brick has a width. Brick dot position width, height. Brick dot position height. Position X brick dot position dot mid X Y brick dot position mid Y, and then to animate when a brick has been hit, we just use .ease in, and then set the value to brick dot is hit. On line 37, we can remove the full stop, that's not needed. The next thing we have to do is to draw the paddle so that the user can move left to right. We use another rectangle, dot fill, magnet active. So if magnet is active, then the color will be cyan, else it will be red. Frame, width, paddle, position, width, height, paddle, position, height, and that sets the paddle size. The next thing we need to do is to set the position of the paddle. Paddle position mid X, Y, paddle position mid Y. And then we will also, there should be a full stop at the beginning of line 46. We should also animate the paddle movement, so we need to use dot animation, dot ease out, or ease in out. The value will be paddle dot position. So the next thing we need to do is to create the falling balls. For each balls dot indices ID self index in and it should be on line 49, it should be balls with an S at the end, not ball. So we need to also implement the trail of the ball for each ball's index dot trail indices ID self trail index in. That's within the closure. So to create the ball, we need to use a circle shape, and then we fill the circle with the color white, opacity 0.3, dot frame, width 5, and height is 5. And that sets the trail circle size. And then the next thing we need to do is to position the trail circle. Trail index. We'll just compile it to see if there's any errors. Cannot find color. Import SwiftUI. So we need to import SwiftUI into the particle file so that the color can be found, or so that the namespaces and imports can work. So the next thing we need to do is to create another circle on line 57, anywhere up line 57, 58, it's up to you. And then we fill the circle with a green color. The frame 20 and the height 20. That sets the ball size. And then the position of the balls, or each of the balls using the index. Just compile it again. In next week's tutorial, we will implement some of the particle effects. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Want to create your very first iOS app, but not sure where to start? Well, you're in the right place. Let's get started. In this tutorial, we will implement the Power Up features to give the player additional lives and extended paddle with extra balls. We will also start to implement the particle features as well. So we need to continue from line 64 or anywhere after line 64 and enter the following. For each power ups, power up in if power up is active, then create a circle and fill the circle with the power up color. I think we need to create a function called power up color. Yes, we do, as we didn't create it in the previous tutorial. So let's create that function. Create the function anywhere after line 77. Private func power up color. This function will accept a power up type and then return a color. Switch type. Case dot expand paddle. So if case is to expand the paddle, then we return, or the system will return, a yellow color. Case dot extra line. return dot green, case slow ball, return blue, case extra ball, return pink, case magnet paddle, return cyan, case reverse controls, return purple. So these are our power up features that we just created. So now we need to return back to line 71. So on line 71 we need to pass the power up type to the power up color. And that will set the color based on the power up type. We also need to add a frame with a width of 20, a height of 20, which is the size of the power up. And we also need to position the power up to position it on the screen, and also to animate the power up. So we use .easeIn, value power up, .active or is active. So the purpose of line 74 is to animate the appearance of the power up, which will change depending on the value of is active and .easeIn. So the next thing we need to do is we need to create our particles. And to do that, we need to use a for each loop, like what we've done previously for the power up. Type in for each, particles, particle. So each particle will be a circle. It's a bit similar to the power up, so I just copy the lines between 71 and 74. Paste it there. And then modify the rest. Particle color. The width is particle dot size, and the height is particle dot size. Position is particle dot position, and the opacity is particle dot opacity. And for the animation, will be a little bit different. So we use the duration for the animation, which is half a second. The value will be particle dot opacity. That will animate in a fading manner. On lines 84, that should be ease out, not ease in. And lines 83, that should be particle dot opacity. Seems like it's spelled correctly. Let me do it again. Okay, so we need to fix something within the particle struct. And we also missed out one of the cases within the power up color function. So we missed out one of the switch cases. So the case that we need to include is shrink paddle. That should return grey. So it reduces the size of the paddle to make the gameplay a little bit more difficult. Also, on line 84, we need to remove that comma. And then we need to have a closing bracket after 0.5. So we didn't need to update the struct of the particle. So the struct for the particle, which is here, it's all okay. So nothing changes there. I'll just compile it again. So the next thing we want to do is to give the user the ability to view their scores and the remaining lives that they have. So we can implement this feature anywhere after lines 85. We will add it or include it within a VStack spacer. We use a spacer to display the scoring and lives. at the bottom. Stat. So we need a text element. To score. We will just style the text element with a foreground color of white for the font text, and then add a bit of padding using .leading. Add another spacer, text element to display the amount of lives. And then the foreground color, that will be white. Another spacer, text, and this is to display the current level that the user is on. Foreground color, got white, padding, trailing, got padding, bottom 20, got frame, width, geometry, got size, got width, height 50. So that just sets the frame for the display. Dot background, dot black, dot opacity 0.7. That will give a semi-transparent background to the score, lives, and level of the VStat. In the next tutorial, we'll start to implement the pause functionality and the game over screen. Thank you for joining us. If you found this tutorial helpful, please comment, like, and subscribe. See you next week. Want to create your very first iOS app, but not sure where to start? Well, you're in the right place. Let's get started. In this tutorial, we will add the resume, pause, and the game over VStat. Anywhere after lines 108, add the following: VStat, button, action, next type in pause dot toggle, so when the user clicks the button, the game will be paused. For our button text or caption, we need to add a text element, pause, and resume. So lines 115, what this does, depending on the state, it will either show pause or resume on the bottom caption. You just add some style to the font, to the title, which is title 2. And as you can see, pause is now displayed on the corner left, on the left hand corner, which is here. The foreground color white, dot padding, background, grey, dot opacity, 0.7, and that's for a semi-transparent background. So it can't find grey, so it seems like we have to use color with dot grey. Dot corner radius, is 10, and that's for rounded corners of the bottom. Add a spacer to push the button to the top. But the spacer is in the wrong place. It should be anywhere after line 121. Also need some padding for the buttons container. Let me give it a padding of 20 just to see what it looks like. And then we also create a pause overlay. So just type in if pause and display the text. Pause. Then we can copy lines 116 to 119. And that should be large title. Color.white stays the same. Opacity, that should be color black. And then we just need some padding. And then the next thing we need to create is our game over screen. Our game over VStack. Game over. So if game over is true, then display this VStack text. Game over. Font dot large title dot foreground dot white dot padding button action. We also need to implement a restart game method. We do this next week or tomorrow. So just comment that out to add a restart method. And then for the button caption, we also need a text element. With the word restart. And I'll just copy lines 129 to 132 again. The font type should be title. The color. Foreground color is white. Padding. Background color is color.green. And then the corner radius is 10. And also we need to add padding to the button. Padding. And then we just add a background color, which is color dot black dot opacity. 0.8. And that is a semi-transparent black background. And then we just need ignore or edges, ignore safe area for all. So the view will extend to the edges. So now let's see if we can show the game over screen. I mean VStat. So if I change game over to true, let's see if the preview refreshes. With my MacBook, it is so slow. It shows it a little bit, but that should be more centered. But we can fix that in next tutorial. So please comment, like and subscribe if you haven't done. And see you tomorrow. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Want to create your very first iOS app, but not sure where to start? Well, you're in the right place. Let's get started. In this tutorial, we will implement the game loop and set up brick methods. The purpose of the game loop is to update the game state every quarter of a second. The setup brick method displays the correct brick type. After lines 158, enter the following. Dot on a pair. So we now need to create our setup brick method. Private func setup bricks. That accepts a CG size. It will calculate the size, the height and the width of the brick. The next thing we need to do is to I don't know why it's showing an error. Oh, this should be after lines 168. So I'll just move this. And place it anywhere after lines 163. So the next thing we need to do is calculate the width of each brick based on the screen size. Let brick width equals size dot width divided by CG float. Number of columns we cannot find the variable number of columns. I thought we defined it in the first tutorial. Let me scroll up. It seems like we missed out number of columns. The number of columns has already been defined on line 25, defined as a constant, but it's not in the right casing, so we need to change the O to a capital O. And now the variable should be in scope and seen. Yeah, there it is, number of columns. Next thing we need to do is to set the height and size of each of the bricks. Let brick height CG float equals to 30 pixels. And then we have to randomly choose the number of rows for each of the bricks. Equals int dot random 4 to 6, which has 3 dots. And then the next thing we need to do is to create an array of bricks based on the number of rows and columns. So to do this, we need to also use a loop. Bricks equals 0 dot dot less than number of rows dot flat map row in and then we need to loop over each column to create the bricks in each row. Zero dot dot number of columns dot map column in let type brick type equals row mod 3 is equal to 0. else it would be a multi-hit. Row mod 5 is equal to 0. Then explosive, else is normal brick. So on line 176, we just determine the brick type based on the number of rows, or the row number. So the brick types can be a multi-hit, or explosive, or normal. The next thing we need to do is set the brick type durability, such as the brick type strength. The strongest brick types at the moment are multi-hit bricks. They have to be destroyed or by that multiple times. So we'll just implement that. Let durability equals type equals dot multi-hit 2 or 1. So if the type of brick is multi-hit, that means we have to destroy it twice. If it's a normal brick, the durability is just once, so we just destroy it once. And then the next thing we need to do is to calculate the position of each brick based on its row and column. That position equals CG rect X CG float column times by brick width Y CG float row times by brick height width brick width minus 2 height brick height minus 2 and then we need to return a new brick object that includes the calculated properties that we define within setup brick. Return brick is hit false type durability, position. Just compile it. So the next thing we need to do is to return to our dot on a pair on line 161, and then implement the following. Set up bricks. So we now can call our setup bricks method. Initialize the bricks layout, geometry, dot size. We cannot find geometry. Let's see if they've defined it at the top. So here is geometry on line 28. Maybe I spelled it incorrectly, but just copy and paste it. Still can't find it. I had to restart Xcode, and now it seems like it's picking up the geometry variable, and it's now compiled. So the next thing we need to do is to create our game loop function, and that is called start game loop. And as you can see in the preview, that's what it looks like on the right hand side. Private func start game loop. As I mentioned earlier, we'll update the game state every quarter of a second. Schedule timer with interval of 0.016. Repeat is true. The invocation, we don't need that. There should be an R at the end, the timer. And we just need to check that it's not in pause mode. If not paused, then update the game. So just call update game method. And that method we need to create in our next tutorial. Just compile it. So let me comment that out. and then on line 157, you'll call the start game loop function. Recompile. So there's an error, schedule timer. That should be with time interval. I'll just build it again. In the next tutorial, we'll implement the move paddle functionality to enable the user to move the paddle from left to right. As you can see on the screen here, this is the paddle. So the ball will bounce off the paddle and collide with the bricks to destroy the bricks. So that's for next tutorial. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Want to create your very first iOS app, but not sure where to start? Well, you're in the right place. Let's get started. In this tutorial, we will implement the move paddle method to enable the user to move the paddle from left to right to capture the falling ball. This will be a shorter tutorial, so let's get started. So the function that we need to implement, we can do it anywhere really, but I'll just do it after line 200. It's private func move paddle to xcg. That should be CG float in size, CG size. Let movement equals reverse, controls, question mark, -1, else 1. So what that does, it reverses the movement direction if reverse controls is active. And then to update the paddle position within the screen boundaries, we need to type the following: paddle position dot origin x equals min max paddle position dot origin x plus cg float movement times x minus paddle dot position dot mid x comma 0 comma size dot width minus paddle dot position dot width. And that will update the paddle position within the screen boundaries. Now just compile it. Previews, they're running a bit slowly. In next week's tutorial, we will add collision detection and enable the ball to bounce off the wall and the paddle. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Want to create your very first iOS app, but not sure where to start? Well, you're in the right place. Let's get started. In this tutorial, we will add collision detection and enable the ball to bounce off the wall and paddle. So the first thing we need to do is to create a new function anywhere after line 228. Name the function private func update game. Guards not game over. So if the game is over, then we just exit the function, else if it's not over, we just continue within this function. For index in balls dot indices, so we're looping through the balls array. Balls index position x equals plus equals balls index dot velocity dot width. The purpose of that line is to move the ball horizontally across the screen. I'll just copy lines 234. The next thing we need to do is to move the ball vertically. So we just use position.y. And instead of using the width, we use the height. Balls index dot trail dot append balls index dot position, and that will add the current position to the trail, to the ball trail when it's moving. So you see like little faint lines. If balls index dot trail dot count is more than 10, then we need to limit the trail length of the ball. Dot trail dot remove first. So it's always less or equal to 10, no more than 10. Remove first below. Want to build your own Connect 4 app? Now you can. Download the free source code and start building today. The link is in the description below. The next thing we need to do is to bounce the ball off the left and right walls. So type in the following: if balls index dot position dot x is less than 0, or balls dot index dot position dot x is more than UI screen dot main dot bounds dot width. Then balls index dot velocity dot width star equals -1. The next thing we have to do is to bounce the ball off the top wall, similar to what we just done. So it's if balls index dot position dot y is less than 0, balls index dot velocity dot height times equals -1. Set up a Patreon to help upgrade my equipment. I'm aiming for a new MacBook Pro, which costs £4,000, to improve video editing and audio quality for better tutorials. If you'd like to support, the link is in the description. Thank you so much. The next thing we need to do is to check for collision with the paddle. So we need to check if the ball is colliding, hitting the paddle. If paddle.position contains balls index position, let hit point equals balls index position x minus paddle position min x divided by paddle position width. Let angle equals open bracket hit point minus 0.5 times by 0.5, and that will calculate the angle of the reflection of the ball when it hits the paddle. Balls index velocity width plus equals angle times balls index velocity height. The next thing we need to do is to reflect the ball upwards. Balls index position y equals paddle position min y minus 10. And the purpose of that lines 254, is to adjust the position to avoid multiple collisions. So that should be paddle position There should be an I there, minus 10. If magnetic active balls index dot velocity equals CG size width and height overloads we need to use. So that will be 0 and the height will be minus abs balls index velocity height, and that what that would do, that will set the velocity for the magnet effects. So in the next tutorial we'll check for collision detection for the bricks. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Want to create your very first iOS app, but not sure where to start? Well, you're in the right place. Let's get started. In this tutorial, we will check for collision detection with the bricks and increment the score each time the ball hits a brick. So the first thing that we need to do is navigate to line 260 and then type the following. For I in bricks dot indices where not bricks I dot is hit. So where the bricks haven't been hit, if bricks dot position dot contains the ball index position. If bricks, open bracket I, dot type is equal to multi-hit and bricks dot durability more than 1, then bricks durability minus equals 1. So what that does, it will reduce the durability for the multi-hit bricks. Else it will mark the bricks as is hit, is true, so the bricks have been hit. Now that the bricks have been hit, we then update the player score by 10 points. If bricks dot type is equal to power up, drop power up. So we need to create a new method called drop power up. So let's create that method now. Private func drop power up at x cg float y cg float. And the purpose of that function is to drop a random power up at a given coordinate. So we will implement that part now. Let random power up equals to power up type dot all cases random element question mark extra line. Power ups dot append. So we append the new power up that has a type which will be accepting a random power up, and the position which will accept an X and a Y. The parameters that we just passed in previously within this function. So now we have to go back to line 268 and call the new function that we just created. Want to build your own Connect4 app? Now you can. Download the free source code and start building today. The link is in the description below. At bricks, I dot position dot midx, and for the Y parameters we need bricks. So get the bricks from the array, position dot mid Y, and that will drop a power up to that function. Bricks was spelled incorrectly. The next thing we need to do is, oh yeah, and on line 267 there should be a full stop and then dot power up, which is there. So line 270, we need to add particles to have a particle effect. So we need to create that function. That function we'll create later. I'll just add a comment. The next thing we need to do is to reflect the ball using velocity. Type in balls index dot velocity dot height times equals -1. And then we also need to check for level completion. So we'll add that method later. And then we would need a break statement. Set up a Patreon to help upgrade my equipment. I'm aiming for a new MacBook Pro, which costs £4,000, to improve video editing and audio quality for better tutorials. If you'd like to support, the link is in the description. Thank you so much. The next thing we need to check is to see if the ball has gone out of bounds. Balls index dot position dot y is more than UI screen dot main dot bounds dot height. If it has, then remove the ball using the index. If balls is empty, then reduce the lives by 1. If lives is more than 0, then we need to create a new method which will be called reset ball and paddle. Else, if the player has used all of their lives, then we need to end the game, so game over is true. And then we also stop the game timer. And then we also need to call update power up and particle methods. It's not been defined as yet, so we need to add this method as well. In the next tutorial, we will implement some of the methods, such as add particle effects methods and some of the other methods that we have commented but not defined. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Want to create your very first iOS app, but not sure where to start? Well, you're in the right place. Let's get started. In this tutorial, we'll start to add the particles functionality. So the first function that we will add is called add particles, and we add that after lines 299. Private func add particles at x cg float y cg float. The next thing we need to do is to create a loop between 0 and 10. And the purpose of this loop is to create the particle effects 10 times. So to create the particle effect within the loop, we have to create a new instance of the particle class. So we need to pass CG point and the coordinates x and y. Which is the position of the particles. We also need to set the velocity, which is width and height. So that will be CG floats dot random in minus 2 dot dot to 2. There should be 3 dots there. And then the height is also CG float dot random in minus 2 dot dot 3 dots to 2. And what we're doing here, we're setting the random velocity within a range for both x and y directions. And the size will be CG float dot random in 5 dot 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 10. And that sets the random size for the particles between 5 and 10. And then we just set the color, which is white, and the opacity, which is 1.0. The next thing we need to do is to add that particle instance to our particles array. Should be particles dot append particle. Just compile it. Want to build your own Connect4 app? Now you can. Download the free source code and start building today. The link is in the description below. And now we need to go back to call our particle method, which is here on line 270. Add particles. Bricks. So we pass the array of positions. To our particle function. And we also pass the mid-y position array to our particles function. And that should be mid-x with a capital X. So the next function we need to implement is called update power up and particles. Private func update power ups and particles. For I in power ups dot indices where power ups is active within the array. Power ups position dot y plus equals to 2, which will move the power up downwards if paddle dot position contains power ups position then you need to create another function called active or activate power up. We'll create that function later. And then power ups, open bracket, I, close bracket, is active, is equal to false. So what that will do when we implement the function, it will activate the power up if it touches the paddle, but we need to create the function activate power up, which we'll do like later or in another tutorial. Next thing we need to do is to update the particle effect. For I in particles or indices, particles dot position dot x plus equals particles dot velocity dot width, which will move particles horizontally to help upgrade my equipment. I'm aiming for a new MacBook Pro, which costs £4,000, to improve video editing and audio quality for better tutorials. If you'd like to support, the link is in the description. Thank you so much. And to move the particles vertically, we need to do something similar. We can just copy line 307, change it to Y for the position. Velocity should be dot height. And then to decrease the particle opacity over time, we just type in dot opacity minus equals 0.02. And then to remove particles that are no longer needed, we just call the remove method of the array, or remove all method. $0, opacity is less or equal to 0. And that will remove particles that are no longer visible. So now we can call the new method on lines 293. Let's call it here. I'll just compile it. Just compiling at the moment. In the next tutorial, we will create the activate power up function. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Want to create your very first iOS app, but not sure where to start? Well, you're in the right place. Let's get started. In this tutorial, we will create the Activate Power-Up functionality to enable random power-ups to be dropped at given coordinates. We'll implement this function after lines 328. Just type in private func activate power up, that will accept a power up object. Next thing we need to do is to create a switch statement to handle different types of power ups. Case dot expand paddle. So the power up is to expand the paddle, as in increase the width. So to increase the width of the paddle, we need to type in paddle dot position dot size dot width, and then increment the width of the paddle by 40 pixels. And then if the power up was for an extra life, we give the player one more additional life. If the power up was a slow ball, then we loop through all of the balls in the array. And then for each balls within the array, we slow down the horizontal velocity of the width by 0.80. By 0.8. 0.8. And then we do the same thing for the vertical velocity, we slow it down by the height by 0.8. Else, if the power up is an extra ball, then we add a new ball to the game. So there'll be two balls within the game. So it'll be balls dot append ball position CG point. We need the XY overloads 200, 400, CG size. We need the width height overloads. Four, and for the height, -4. If the power up is to shrink the paddle, then we decrease the size of the paddle by 40 pixels. Paddle dot position dot size dot width equals max 60 paddle position dot size dot width -40. And we also ensure that the width doesn't go below 60. That's why we use 60 here. If the power up is magnet paddle, then we just set magnet active equals true. Else, if the power up is to reverse the controls, then we just reverse the controls by setting it to true. On line 333, there should be a code on there, and line 335. I'll just compile it. Want to build your own Connect4 app? Now you can. Download the free source code and start building today. The link is in the description below. up a Patreon to help upgrade my equipment. I'm aiming for a new MacBook Pro, which costs £4,000, to improve video editing and audio quality for better tutorials. If you'd like to support, the link is in the description. Thank you so much. The next function we need to add is to check if the level has been completed. So if the level has been completed, we need to increment the level by 1 so that the game goes on to the next level. So to do that, we just type in private func check for level completion if bricks dot all satisfy $% dot is hit. So what that does, it checks if all the bricks in the game have been hit. If all the bricks in the game have been hit, have been destroyed, that means the level has been completed. So we increment the level by 1. And we also need to increase the level of the game, the difficulty level. So to do that, we need to create a new function called increase difficulty. We'll add that function tomorrow. And then another function that we also need to call is reset ball and paddle. We'll create that function tomorrow also. And then we just call setup bricks and pass in the UI, screen, main, bounds, dot size. On line 358, what that will do is set up the new bricks for the next level using the screen size. But these two methods we need to create. We'll create it tomorrow. So tomorrow the entire tutorial for this game will be completed. Just going to check to see if we need to call any other functions that we added in the previous tutorial. So on lines 273, check for level completion. We can call that function now because we just implemented it. Check for level completion. And On lines 167, we can uncomment update game. So that's now a function, update game. The restart game, it doesn't exist as yet. We'll be creating that tomorrow. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Want to create your very first iOS app, but not sure where to start? Well, you're in the right place. Let's get started. In this tutorial, we will create the functionality that will increase the ball's speed each time when the game moves to the next level. So the first thing we need to do is navigate to line 367. 362, and then add the following. For I in balls indices. So we're looping through the balls array. Balls I, which is the index velocity, dot width times equals 1.2. So what that does, it increases the ball horizontal speed by 20%. Balls velocity height 1.2, and that increases the ball's vertical speed by 20%. And then to make the game a little bit more harder, we reduce the paddle width by 10%. The next function we need to implement is called reset ball and paddle, which resets the ball and paddle position for a new level after losing a life. balls equals ball position CG point. We need the XY overload past 200, 400. Velocity is CG size. We need the width and height overload. So width is 4 times by power, the power 1.2 double level minus 1. And then for the height, that needs to be minus 4 times by power 1.2 double level minus 1. There's an error somewhere, missed out something. Just compile it again. So what we've done there, we just set the ball's position and velocity, scaling velocity based on the current level. The next thing we need to do is to set the paddle's position and size based on the current level. We need the X, Y, width, height overload. X is 150, Y is 500, width is 100 times by power 0.9 double level minus 1, and then height is 20. There's an error on line 373. Missed out something. It must be double level So that's power, open bracket, 0.9, comma, let's compile it again. Want to build your own Connect 4 app? Now you can. Download the free source code and start building today. The link is in the description below. Set up a Patreon to help upgrade my equipment. I'm aiming for a new MacBook Pro, which costs £4,000, to improve video editing and audio quality for better tutorials. If you'd like to support, the link is in the description. Thank you so much. We next need to set magnet active equals false. To disable the magnet power up effect, and also we need to reset the control scheme to normal. Another method we need to create is called restart game. It's private func restart game in size, which accepts a CG size. Game over equals false. Score equals 0. Lives equals 3. Level 1. Power ups, removal all. Remove all the particles. And then reset the ball and paddle, and call setup bricks. So that sets up the bricks for the first level using the given screen size that we pass in, which is size. And then we just call our game loop. On lines 284, we need to call the method that we implemented, which is reset ball and paddle. Also on lines 139, we need to call the reset game method. Reset game What did we call it? Reset game or something else? I mean, restart game. That's what it should be. So we just pass in geometry, dot size, just compile it. And now we can try to run the game to see if it works or not. Hey, there's something else that I missed out. We have to go into the content view and what we need to do, we need to call breakout view on lines 100, on lines 12. So breakout game view, so the view gets shown at the start. Edges, ignore safe area, all. Still waiting for the game to run. Let me try it again. As you can see, this is the game in action. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week.